Yes, perfect.
Okay, yay! All right. So my name's Doug Madory from Kentik. This is another piece of analysis that's part of a long-running collaboration I have with Joe Snyder's. So I'm from Kentik. He's currently looking for his next gig. If you're looking for someone who's a RPKI expert, routing expert, or a 9cat artist, he's your guy. So today, we've been doing a lot on RPKI ROV adoption, but this is we're gonna switch gears in this talk to look at an older technology, AS sets. Many of you probably have your own stories of the challenges these things provide. So I'm gonna run through a little bit of analysis here, and I hope you find this interesting. So right off the bat, I want to do a quick disambiguation on the term AS sets. So this is a talk about AS sets, not a talk about AS sets. So we've got, just in the BGP parlance, we have a lot of overloaded terms. This is another one. So this is about the IRR AS set object type used for routing policy, not the BGP AS set construct, which has been recently deprecated, so you shouldn't be using that anymore. That's RFC 9774. That one is, if you see it in BGP data, so you like little curly braces, you got multiple ASs. It's an attempt to try to consolidate messages, announcements, so that you'd have multiple origins show up for multiple prefixes. The problem is that it breaks any kind of origin-based routing filtering, like RPKI ROV wouldn't work if you lost the association between the origin and the prefix. But the BGP AS set is not what we're going to talk about. We're going to talk about the IRR AS set. So with that out of the way, let me get into a BGP leak. So this is where we use, typically, is one of the use cases for an AS set, is to try to mitigate the impacts of a routing leak and try to limit the propagation of problematic routes. So there's many to choose from. We'll take one I started looking at about a year ago. This happened in March 11, 2024. It's a Russian mobile operator. Mostly it does transit as well. Leaked about 30,000 routes learned from HKICs onto a couple of transit providers. One thing that's unique about this is, I'll give credit to Curator. I have a collaboration with them. They post a bunch of leaks there. It's really the BGP nerds that really get into these. I'm one of those to try to dig into when these things happen. They still occur with some frequency. And then the graph on the left is, so as a BGP guy at a NetFlow company, I have the benefit of being able to take a look at, how much traffic do we see impacted by some sort of routing mishap? And so, for many years at Renesas and Dyn and Oracle, we would look at BGP incidents in kind of isolation, assume there stands to reason maybe some packets were impacted. Now we've got a slice of the traffic going through the internet to take a look at, and then we can run a query and see how much traffic got either misdirected, or more often than the case, traffic gets dropped because it's getting misdirected through a link that's getting overloaded. So this was a little graph of the spike by whatever country. We could do destination AS. Anyway, so this is a leak from MTS. Another little quick aside on this. This is something I see regularly when we have routing leaks is regional routes. Maybe you have them down here in Australia as well, where you've got a route that is intentionally limited, the propagation is limited to maybe just this part of the world. It is often more specific, and so that becomes an issue when it gets leaked out and there's nothing for the leaked version to contend with and kind of fills in the vacuum. And that's what we're seeing here with this Netflix prefix and this graphic where we're looking at the timeline going across. We're looking at what are the penultimate AS to get to Netflix through time based on route BGP sources. And so when the leak occurs, then that gets filled up with HKICs. Looks like it's the biggest upstream for Netflix because this leak is getting passed through them. So that's a risk that sometimes is incurred with these regional routes, and there's typically an operational impact to it. All right, so back to AS sets, and we'll tie this back to the leak here. So this is as you maybe may or not know, so a special database object type representing a group of ASNs and potentially other AS sets that's used for route filtering, Policy control by network operators. They're used to generate an allow list. That's my term. It's not in the literature, but you get the idea. Whitelist from an AS set. And the way it's built is you're going to recursively go through each member. If it's an ASN, we're going to look for the route objects that contain that ASN in the field, turn it into a set of prefixes, or if it's another AS set, then we recursively start this process over again. And then you got a resulting, potentially, in some cases, we'll see a very long prefix list that is what are the routes that you would allow if you were to see it across a BGP session. So you would apply this to a running configuration to your AS neighbor in question. But there's challenges here for AS sets. There's no inherent quality, integrity, authentication controls over the content. There's no limit to the number of AS members or AS sets that can be included. There's no limits on the depth of the resulting recursion, which allows kind of unlimited unchecked growth. I wrote a few years ago an analysis of BGP prepending that is kind of still, there's a lot of prepending that is out there that serves no purpose, and it just kind of accumulates. Anything in the internet space that can grow unchecked will do so. The one thing about this recursion too, you can also have you can have like a loop here where you can include an AS set that includes the original AS set, and all kinds of crazy stuff is possible here. And then there's also, we'll talk about this a little bit, there's not really a common understanding of the use cases of AS sets, and so this is an area where there's a need for some kind of convention getting established of like, what are the different types of AS sets? Is it a list of customers? Is it a list of peers, your transit providers or IXB members? And then how would those AS sets be included in each other? Because that's probably a lot of the problem is some of these shouldn't be included. So, there's maybe a complicated sentence here at the end. If you have an AS set that includes another AS set that has another AS set, you can see how the original AS has lost control and lost awareness as far as what's included. If you ever in your youth invited a couple friends over to a party and said they can invite somebody, and then they go invite somebody else, and you end up with 100 people showing up at your house. We've got the same thing with the AS sets. So back to that leak in 2024, MTS uses this AS set ASMTU. We use Ben's BGP tools tool to list the contents of this AS set. We can see that it expands to about 43,000 ASNs. I made these slides a couple months ago. These number might be off a little bit, and there's give or take about 83,000 ASs in the global routing table. So we're including over half in this one AS set of this one Russian network. And then if you go in it. If you were to apply this to an interface, you would create an allow list that is pretty massive and includes a lot of things that I think we could probably all agree probably shouldn't get passed through a Russian network. We have there's U.S. Department of Defense networks, rural telephone service in Kansas, American Express, AWS. There's government networks. There's all kinds of things that come through here that probably shouldn't be. Another tool that people use to generate their allow lists from AS set is BGP4Q. Maybe some of you have used that. So just looking at some examples here, if we were to try to run and have it generate a Junos configuration, just to pick something at random, we're going to have output that's 1.3 million lines long. There is an option to aggregate, and that brings it down to 271,000, but you can imagine this is a lot of configuration you're going to add for this one network that is actually going to almost defeat the whole purpose of the AS set. In this case, if you were to expand this to the prefixes, count up the unique addresses, we're at 1.8 billion unique addresses out of, if possible, about 3 billion that are currently in the v4 routing table. This is too broad of a definition. It's also, a word of caution too, if you're, you may know this already, but these AS sets can really vary by the source IRR. We're using an example from Voxility because I wrote another post earlier this year looking at a BGP leak through Voxility. At least in Voxility's case, maybe an argument can be made, since this is a DDoS mitigation provider, that its AS set maybe needs to be pretty broad, and they could be potentially translating something from all over the world. But you can see, depending on what IRR source you're using, just by line count, you can see that these things are massively different, which is partly why you'll see in peering DB, there's a requirement that you specify what's the IRR of the AS set if you're going to include that in your entry, because it's pretty important. It depends. It can change pretty wildly based on the source. All right, so I started to compile a list of what were the worst, just coming from this incident, and then I reached out to Ben, and he was good enough to, because I figured he already kind of had a lot of this computed, and more or less he did. So thanks to him, he generated a big list of like what were the worst AS sets, just by how big they are, of how many ASs they expand to, and these things are kind of ludicrous. The biggest ones, there's many that contain more than the ASs in the global routing table. We have 2,200 AS sets to expand to over 1,000 ASNs, and there's probably a very few number of ASs that could legitimately justify that size of a customer cone or some reason why they would have a legitimate AS set be that big. I will point out that I don't know that these are in a router configuration. I don't know that these are actually getting used, so that we're kind of setting this in a vacuum, because I'd have to be in a router config to know where any of these get made use of. But in talking to network operators at various NOGs over the last year or so, asking how they struggle with this problem, it's a well-known issue that I guess I'm trying to bring some light to. So as I mentioned, if you notice, I said earlier, give or take about 83,000 ASs in the global routing table. Where are all these other ASs coming from? They come from this myriad of downstream nested AS sets. And Ben and I were talking at Apricot a few months ago, and I was like, oh, could we trace these through? And so he did that for a couple of these, and we'll look at one of these examples. This AS set, AS XUA UA from RIPE, expands to about 90,000 ASNs, including many unrouted ones. Why? Well, how did the unrouted ASN wind up there? I guess we don't really care so much about that answer, other than just to look at this crazy path of nesting. And this is not that unusual to have this kind of nonsensical nesting. So in this path, if you were to look at it, there's some indicators of geography here. You're starting in Ukraine. We go to Bulgaria at this IX, Netherlands, another IX, Russia, TTK, so it's Trans Telecom, the transit provider, over to China, South Africa, then to China again, then to Russia again, to include the AS that is the unrouted AS for the public corporation for the organization of air traffic in the Russian Federation. I guess they didn't need that one. So as I was talking to people about this issue who kind of wrestled with this, one idea that had come up was that there's, like I said earlier, there's not really a convention around how do different AS sets get used? And this is all, people are kind of making it up on their own separately. And so I tried to just, again, looking at from the names of these AS sets, try to classify them as what type of AS set might this be? And so we've got green are ones where you've got an AS set that's defining your customer cone. Then you've got IXP members, and IXP may have an AS set just for the members in case you want to apply a policy to any of the routes you're getting from the IXP. But why some of these things would be included, you can see how that could be problematic, right? If you have an AS set that's your customer cone, and in it are IXP AS sets that are kind of operating laterally, you're going to create kind of a valley-free violation here. Or if it's a set of peers for an AS, then you're going to have, it's going to allow a lot more problematic routing that you would like to use the AS set to avoid. And this ends up exploding the size of these AS sets. This is one of the key factors. All right, so why is it a problem? So I don't know that this leak in March 2024, again, I'd have to be in the routing configuration of the upstreams to know if they were, to what extent this excessive AS set kind of whitelisted a lot of the leaked routes they end up sending around the internet. Stands to reason it probably wasn't helpful, I would imagine. And then, taking a step back, our only hope at any of this improving routing hygiene is trying to improve automation. And so the upside of the IRR data, this is an automated system. It's got obviously clearly some issues here, but we have to be able to automate the generation of these allow lists, these session filters, and but these excessively large AS sets defeat the purpose of the allow list, and it's even worse, right? So this also breaks a lot of people's automation. So again, talking to people directly, they've had to write their own software to deal with how to pare down an AS set. I gave this talk in AusNOG in June, and we had a few people come up to the mic to talk about some of their solutions of what they did to try to address this. Somebody came up and said, well, we monitor a session and look at the routes that we see across it and then build a profile that's going to be the allowed list. I guess that's good as long as it never changes. But if you had, if you're upstream to a DDoS mitigation provider, what it's transiting from one day to the next might be completely different. So you can't learn your way out of this in all cases. But the other thing is that you're generating these potentially really long, really huge router configurations, and most of it's a waste. And you're also updating it. Most networks are updating this information, at least daily, maybe multiple times a day, pulling over all of this data, creating this configuration that's going to be useless, and loading it into a router potentially, or applying your own software. So, like I said, a lot of people have had to come up with workarounds and trying to raise this as an issue and see if we can come up with some ways to provide a solution. So, for you network operators out there, if you have an AS set, you might want to take a look at, is it the minimum number of things that are in it? Do your AS sets include other AS sets? Now it's expanded your whitelisting, your allow listing networks that you don't really want to pass, and now this is part of your routing hygiene. Ideally, recursion, you'd like to keep this to a minimum. I know I got pushback from some tier ones who were like, well, I've got transit customers and they've got transit, or they've got customers and they've got, I can't keep track of the whole cone. I need the recursion in order to build that list out of my customer cone. So I understand there's the use cases where that's necessary, but as we can see, like in a lot of cases, it ends up kind of just exploding the list to make it kind of unusable. And this solution requires work of people to dig in manually and figure out what's in these AS sets. Something that one could argue is unrealistic for a global internet routing system. So then, if we had a magic wand and we wanted to try to come up with a new system, we probably are going to have to eventually move away from IRR-based route filtering. Perhaps a controversial statement, I don't know, but we've got a few technologies here that kind of try to cover some of this problem space. So RFC 9234, this is the OTC where an AS tries to signal to another to say, this is only to customer, or to understand what type of AS relationship is getting shared. That auto, if both parties are speaking the same language, then an AS could recognize immediately that I'm getting networks that I shouldn't get and reject those before they become a problem. We've got ASPA verification. It's kind of another work in progress. We have some adoption here, but we almost need an ASPA just for AS sets. Like if we knew once they appear, you wouldn't want to have that appear set. You wouldn't want to have that in your customer cone because you'd be kind of defeating the restriction of the customer cone. And then we've got things like signed prefix lists, or maybe way off in the future. But our current system is what we have. It lacks obviously this degree of precision, and and awareness of what's in it for automated route filtering. So we're gonna have to have some kind of combination of inbound, out of bound. Inbound would be like the OTC, out of band, the RPKI-based solutions to try to figure out in an automated fashion if a route is legit or not. All right, so I want to say thanks to Ben for his work to help me on with the BGP tools, and a couple other guys, Tony, Aaron, Anis, and Lasse from Telia. And I want to ask, does anybody here have an AS set that they have had some problems or customers with excessive AS sets? Is this a problem that anybody here wrestles with? If you do, I'd be curious to know. What is it that you do? All right, thank you.